Okay, Hunter, here we go. Determine the probability of having one girl and 3 boys in a 4-child family, assuming that boys and girls are equally likely. So for the first child, you have 2 choices. For the second child, you have 2 choices. For the third child, you have 2 choices. Fourth child, you have 2 choices. So it's 16. 2 times 2 times 2 times 2 is 16. Now here are the ways this can happen. You can have the girl first and then 3 boys. Boy, girl, and then 2 boys. Boy, boy, girl, boy. Or boy, 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 girl. So the girl could be first or second or third or fourth. That's the only way it'll happen. So there's 4 options out of 16, which is 1/4. This tree diagram did not help me at all, so I don't want you to think about that. So it's 4 out of 16, which is 1/4. Number 2 says you toss a coin 200 times and you get 26 heads. Determine the relative frequency probability. Well, that means from the activity that you did. So 26 out of 200 is 13 over 100 is 0.13. You can put that right in your calculator. 26 divided by 200 is 0.13. The next one, what's the expected frequency? Expected frequency means what's supposed to happen. Well, if you're tossing a coin, half the time you're supposed to get heads. So 100 out of 200 should be heads, which is 0.5. Do you have reason to suspect the coin is unfair? Yes, because the relative frequency is not near the expected frequency. Number 3, determine the probability of the given opposite event. What is the probability of rolling a fair die and not getting an outcome less than 5? Well, if you don't get one less than 5, it means you got 5 or you got 6. So 2 out of 6, which is 1/3. Number 4 says make a probability distribution for the given set of events. The sums that appear when 2 fair 4-sided dice with 4, 5, 6, and 7 are tossed. Okay, so here's the deal. It could land 4, 4, 4, 5, 4, 6, 4, 7, or 5, 4, 5, 5, 5, 6, 5, 7, or 6, 4, 6, 5, 6, 6, or 6, 7, or 7, 4, 7, 5, 7, 6, 7, 7. Then I go through and I look at my sums. The sum of 8 can come from this one right here, 4 and 4. Nothing else is going to give me 8, so it's only 1 out of 16. The sum of 9, I could get 4 and 5, right there, or 5 and 4. Well, I put check marks, didn't I? So there's 2 of them that'll give me 9. Nothing else will give me 9. 2 out of 16, which is 1/8. The sum of 10, 4 and 6, 5 and 5, 6 and 4. So there's 3 out of 16. The sum of 11 could be 5 and 6, 6 and 5, 7 and 4, or 4 and 7. So there's 1, 2, 3, 4. So it's 4 out of 16, which is 1/4. The sum of 12 could be from 5 and 7, 6 and 6, or 7 and 5. There's 3 of those, 3/16. 13 could be 7 and 6, or 6 and 7, which is 2/16, which is 1/8. The sum of 14 is right here, the only one, and it is 1/16. So make you a list and go from there. The odds on your bet are 7 to 5. If you bet $45 and win, how much will you gain? Set up a ratio. 7 over 5 is equal to your winnings over 45. And then you can cross multiply, or you can look at this and say 5 times 9 is 45, so 7 times 9 is 63. Or if you had cross multiplied, it would have been 45 times 7 equals 5 times question mark, and 45 times 7 is 315 divided by 5 is 63. Would it give you that? Use the theoretical method to determine the probability of the outcome or the given event. The next president of the United States was born on Tuesday, Wednesday, or Thursday. That's a probability of 3 out of 7 because there's 7 days in a week. Suppose there's a bag containing 15 pink marbles, 15 violet marbles, 15 red marbles, and 15 black. Someone mixes the marbles thoroughly, draws one marble at random, and puts the marble back in the bag. Mixes thoroughly and draws another marble. Complete parts A through B. These are all the possible ways. It's kind of like that problem with the numbers. 4, 4, 4, 5, 4, 6, 4, 7, 5, 4, blah, 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 blah. So this is pink, 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 violet, pink, red, or pink, black. Violet, pink, violet, 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 red, violet, black, and so on. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 possibilities. What's the choice with 0 violets? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sixteenths. 1 violet. 1, 2, 3, 4, 5, 6. 6 out of 16, which is 3/8. 2 violets. 1 time. 1/16. A person can order a new car with a choice of 10 possible colors, with or without air conditioning, so that's 2 choices. With or without automatic, that's 2 choices. With or without power windows, that's another 2. And with or without a CD player. So how many different ways can you order a car? 10 times 2 times 2 times 2 times 2, which is 160. The next one says, suppose that event A has a 97% probability of occurring. Event B has a 94% probability of occurring. Both are high probabilities. Compute the odds. Well, to compute the odds, you take the probability of it happening and divide it by the probability of it not happening. So it's 0.97 over 0.03. I got 0.03 because I did 1 minus 0.97. So 0.97 divided by 0.03 is this number, 32.3333. The next one is 0.94. So 1 minus 0.94 is 0.06. So 0.94 divided by 0.06 is 15.6667. The difference between the probabilities is only 0.03, but the difference between the odds, when you subtract those, is 16.667. The odds are deceptive because they make the difference look larger. Determine whether the following individual events are independent or dependent. Then find the probability of the combined event. Rolling 2 3s by 1 4 on 3 tosses of a fair die. These are independent. The first toss has nothing to do with the next one. So the first toss, rolling a 3, is 1 out of 6. Rolling another 3 is 1 out of 6. Rolling a 4 is 1 out of 6. And when you multiply those together, you get 1 out of 216. Determine whether the following individual events are independent or dependent. Then find the probability of the combined event. Randomly drawing and immediately eating 2 pieces of candy, red candy, in a row from a bag that has 10 red pieces out of 45 pieces of candy. Well, you're going to start out with 10 out of 45, and you're going to draw it, and you're going to hold on to it or eat it, and the next time you're only going to have 44 pieces in there, and only 9 of them are red. So you multiply this together, 10 times 9, divided by 45 times, I'm going to put that in parentheses, 45 times 44, and I get 0.045. So they're dependent events, because when you took and held on to the first one, it changed the numbers for the second one, and the answer is 0.045. Next, it says determine whether the following events are overlapping or non-overlapping. Then find the probability. Drawing either a black king or a red 2 on one draw from a regular deck of cards. Okay, let me redo this problem right over here. How many black kings are there? 2 out of 52. How many red 2s are there? 2 out of 52. And you can do one or the other. They're not asking you to do both. So you add that together and you get 4 out of 52, which is 1/13. And you can put that right in your calculator. Alpha, y equals, and you can do 2 out of 52 plus 2 out of 52, and it's 1/13. Use the at least once rule for find the probability of the event. Purchasing at least one winning lottery ticket out of 10 when the probability of winning is 0.02. So the probability of not winning is 0.98. So it's 1 minus not winning 10 times. 1 minus 0.98 to the 10th. When you do that, I get 0.1829, which is what the book had. Probability of getting at least 1 in 2 rolls of a single fair die. I'm going to pause just a minute. Okay. 1 minus the probability of rolling a 1 and the probability of not rolling a 1. Not rolling a 1 is 5, 6. So it's 1 minus 5, 6, and we're going to roll it twice, so it's squared. When you do that, 1 minus 5, 6 squared, you get 0.305 repeating. They've got it rounded to 0.306 because the 5 right there makes that 5 increase. Randomly meeting either, okay, I don't have a way to work that one yet. I'm working on it, Hunter. Just bear with me. Number 17 is the next one that I know how to do. I'll get them other two when we have tutoring. It says a DJ is preparing a playlist of 24 songs, and how many different ways can they arrange the first 6 songs? So we have 24 songs, and go over to the probability button, and we want the NPR one. That's the one we want. Let me do this again. 24, and it's NPR. And you're going to take them 6 at a time. And it's going to give you this number, 9,609,000. Number 18 says answer the following question using the appropriate counting technique. How many different telephone numbers? You can't use the 0 in the first 3 digits. So that means you got 9 choices. 1 through 9. You got 9 choices. 9 times 9 times 9. Can't use an 8 in the next 3. So they give you 9 times 9 times 9. They don't care about the last one. You can use all 10 of them. So it's 10 times 10 times 10 times 10. So here we go. 9 times 9 times 9 times 9 times 9 times 9 times 10 times 10 times 10. And this gives me 5,314,410,000. Their permutations, let me see, 18. 18 is B. It's this one right here. They're arrangements with repetitions because there are selections from a group of n choices and they can be repeated. Okay, that's the end of the video. I hope it helps you when you're getting ready to study for your test.